So with the basis of a random experiment, sample space, and event now being defined, we can talk about what probability means. So probability is a mathematical measure of how likely an event of interest will occur. The probability of an event is a ratio between the number of outcomes of an event and the number of all possible outcomes. So probability can be calculated theoretically by counting all possible outcomes in an event and the sample space. And probability can be calculated empirically by experiment from counting observations. Probability can be expressed as a fractional value between 0 and 1. So here we've got the probability of an event being less than or equal to 1 or greater than or equal to 0. Or probability can also be expressed as a percentage between 0% and 100%. So the probability of an event can be less than or equal to 100% or greater than or equal to 0%. So it is likely that the theoretical probability does not match the empirical probability with a small number of experiments. So remember the law of large numbers, and the person responsible for that, Pearson, actually flipping a coin 24,000 times to have the experimental probability approach the theoretical probability. So here, an example, given a coin toss, which has a sample space of heads and tails, if the event of interest is getting heads, then the theoretical probability of heads is 1 out of 2 or 50%. But it is possible that the first 3 coin tosses result in 3 heads. So the empirical probability of heads would have been 3 out of 3 or 100%. But with a larger and larger number of coin tosses, the empirical probability will approach the theoretical probability. So even though, we tossed a coin 3 times and our probability of getting heads empirically by experiment was 100%, if we kept flipping that coin 10 times, 20 times, 100 times, 500 times, 24,000 times, then that probability is going to approach our theoretical probability of 50%. The probability of a rare event occurring sets the benchmark in hypothesis testing to come to one conclusion or another. So we're going to use this idea of probability later to test whether a rare event has occurred, something outside of what we would normally expect, something outside than what we would theoretically expect. So let's look now at actually calculating mathematically the probability of an event. So we're going to use capital P to mean probability and capital E to represent an event. So we write P of E like this, and that means probability of event E. So here are the properties of probability, and I said this on the previous page. The probability of an event is either less than 1 or greater than 0. Probability is always a positive number. You can't have a negative probability. Or probability can be written as a percentage, either between 100% and 0. And the probability of the sample space is always equal to 1. All right, so here's the equation for the probability of a single event. So the probability of a single event is going to be equal to the order of the event over the order of the sample space. So this is where the probability is a ratio between the number of outcomes in the event over the number of outcomes in the sample space. So in other words, the order of E is the frequency of the outcome of interest, and the order of S is the total frequency of all possible outcomes. Another way of kind of restating this equation would be to think of it this way. The probability of an outcome you're interested in is equal to frequency of the outcome that you're interested in all over the total frequency of all possible outcomes. So let's think of that now when we look at this example. So we're going to look at the probability of a compound event with a single six-sided die experiment. So here our experiment is rolling a six-sided die. We know the sample space of rolling a six-sided die. And our event is going to be rolling a 2 or rolling a 4. And so if we're interested in what's the probability of rolling a 2 or a 4, then in order to use this formula, we need to figure out what the order of the event is and the order of the sample space. So the order of the event is 2 because there are 2 items in the event. And the order of the sample space is 6 because that's the total number of all possible outcomes. And so when we calculate the probability of rolling a 2 or a 4, that's going to be a fraction or a ratio of 2 over 6 because the order of E is 2, the order of S is 6, and that can be reduced down to 1/3. Let's maybe take a look at this visually. You know, if you're having a hard time kind of visualizing what's going on here, and we can do that with something called a Venn diagram. So I like to draw these. So here is our sample space. And inside our sample space, we've got the numbers 1, 2, 3, 4, 5, and 6. And we've defined event E to have 2 and 4 in it. Okay, so now when it comes to calculating the probability of getting a 2 or a 4, you can kind of see, well, we've got 2 outcomes in event E. And as far as the number of outcomes in our sample space, we've got 1, 2, 3, 4, 5, 6. We got 6 total. Okay. So Venn diagrams come in handy, and I'll be using more of them later to kind of show what we're dealing with, our event and our sample space.